The next thing that we will discuss is vector. We will skip linked list for the moment because linked list is a class that not only implements list interface, but also implements the dequeue interface. So we will discuss linked list when we have discussed queue and dequeue. So moving on to vector. Vector is essentially the same as an array list. Everything that we discussed for an array list applies for vector. The only difference is that a vector is synchronized and an array list is not synchronized. What does synchronized mean? It means that vectors are thread safe. We will discuss multi-threading in chapter 8. And when we discuss multi-threading, we will understand more about what synchronized means. But for now, just remember that vectors are synchronized and array lists are not synchronized. So that is one of the difference between vectors and array lists. The second difference is that array lists are a bit faster to use. And that's about it. That's the difference between vectors and array lists. Apart from that, the internal structure is more or less the same. Both of them implement the list interface, and both of them use dynamically resizable arrays as their internal data structure. So that takes care of vectors. Now let's move on to stacks. In this part, the diagram is a bit inaccurate. Stacks do not implement the list interface. They directly extend the vector class. So let's change the diagram. That's better. Now, stacks are essentially inherited from vectors, but we can only use 5 methods on stack. Those 5 methods are specially defined for stack, and those methods allow us to use a vector as a stack. But since stack extends vector, the internal structure of stack is the same as that of vector. We basically just repurpose that structure and use special methods so that we can create the stack data structure. So let's look at stacks a bit more closely. Stacks run on the principle of last in, first out, which can be abbreviated as LIFO. So let's say we have a few elements that we want to store in a stack. Let's say we have 2, 3, 4, 2, 7, 1, and 9. So when we insert each element one by one into the stack, we say that we are pushing the elements into the stack. So at first, we will push 2 into the stack. And so it goes at the bottom of the stack in this position. Then we push 3, then we push 4, then we push 2, then we push 7 into the stack, then 1, and lastly 9. So this is how the data would be inserted into the stack. What if we want to retrieve the data from the stack? Let's say we want to retrieve 4. We cannot do that directly. The only element that will come out of a stack when we want to retrieve data is the element on the very top. That is called popping. So we will pop the very last element in the stack, which is 9. So now when we use the pop command, the very first element to come out is 9. If we pop the next element, that would be 1. If we then pop the next element, that will be 7, and so on. So that is how a stack works. You can think of it as a stack of plates. When you are stacking plates, you place the very first plate at the bottom. Then you place the next plate on top of the previous plate. And then you place the next plate on top of the previous plate. And so the stack grows and becomes taller and taller. But if you want to retrieve a plate, the only plate that you can retrieve is the one at the very top. So the last plate that got into the stack got out first, exactly like it is happening here. The first element that got into the stack went to the very bottom, then the next element, and then the next element. And so the very last element that got into the stack would be retrieved first when we use the pop command. These are the methods that we can access if we create an instance of the stack class. The empty method will test if the stack is empty. It returns either a true or a false. Peek looks at the object at the top. So here, if we use the peek method on this stack, the result would be 2. It would just return 2. It wouldn't remove 2 from the stack. The pop method removes the object from the top of the stack and also returns this object. So if we pop it, we'll get 2 as a return, but 2 would also be removed from the stack. Pushing an item means a new item is pushed on top of the stack. So if we push 7 into the stack now, then 7 goes on top of the stack. And we can also search for a particular object in the stack.